Hello, Mr. Eric, Mr. Ryan, are you right? Okay, so let's talk about this longest increasing path. Okay, we're given this map of integer matrix, and we want to find out the longest strictly increasing path in the matrix. So a path, we can follow the numbers horizontally or vertically. Yeah, there are two directions. Actually, there are four directions. We can go up, down, left, right. So can you tell me that which one is the longest path in this case, everyone?
0, 1, 3, 5, 6, 9, or 3.
0, 1, 3, 5, 6, 9. Okay. Any more?
Yeah. 0, 1, 3, 4, 6, 9.
Okay, so both are the longest, equally longest, strictly increasing path has 6 numbers. Yeah. Okay. So this is the problem when we are solving this today. So any idea? I mean, you can say brute force if you want.
Brute force.
Yeah, brute force. How do we brute force? Okay, so my next question. How do we brute force? Ryan? Eric?
We check every single one.
We check every single one. We check every single pixel. Okay. So let's define.
It might take a long time.
Yeah. Let's define FRC is the representing the longest path starting at pixel RC, the coordinate. Okay. So this actually returns an integer telling the length of the length of the longest. Yeah. Length of the longest. So then we can go through these possible starting position and calculate the maximum of it, right? Answer at the beginning. So what's the minimum? What's the minimum length of the longest path? What's the minimum?
1.
Yeah, exactly. Yeah, exactly. Each number is you can start with any position and it gives us the longest path. At least 1, right? So answer equals 1. And then for R in rows, which rows is the number of rows in the matrix. For C in columns, the columns, how many columns, right? So answer equals maximum of answer.
Does it have to be 3 by 3?
No, rows and columns. Then this is a very simple example, okay? Very good question, okay, by the way. Answer equals max answer, FRC. And then return answer, yeah? So the key thing here is this f function, right? F function. So we start with this pixel and then we want to find out the length of the longest path starting at this position, right? So this is it. So how would we implement this RC function? So if we need to find out if the neighboring pixel, 4 direction, if it is strictly bigger than the current pixel, right? Then we can work, right? So for example, look. Okay, so here, look. If FRC is here, look, it's at 4, right? And I'm realizing that 6 is bigger than 4. So this is what? 0, 1, 0, 1. F11 would be equals to what? 1 plus F, this is what coordinate will be there? That will be 1, 2, right? Right? You see? Yeah? Am I right?
Mm-hmm.
Because if I starting at this position, I can add 1 more pixel and the max is 1 plus. Do you get it? Yeah? 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 Okay, so do you so we can just check 4 direction and to increment this 1. Yeah, if there's a strictly, if the next neighboring, the 4 direction, the pixels on the 4 direction is bigger. One of them is bigger, then we can just extend it 1 more bit, okay? And then, obviously, we need to do one more magical keywords to make it efficient. Cache, exactly. Why is that? If we don't do the cache, what will happen, everyone?
It'll be exponential.
Exponential. How? Look, if we're starting from this point, yeah? And then we somehow we need to calculate f function from this point, f function from this point, f function from this point, yeah? And then we come back to this function, this pixel again, and we need to call this f function again. So but we have calculated this pixel before. Then we don't need to calculate again. So that's the beauty of bringing in the cache. Yeah. Answer equals 1, right? So for the 4 directions, yeah, DR, DC in 1, 0, 0, 1. Are you okay? Minus 1, 0, 0 minus 1, yeah?
Oh.
That's the offset in the 4 direction, right? Then the current, let's define this f function c, right? And then we put a cache here, okay? I'm going to mark it as red. So this is very important because if we don't put this cache, this solution will be infeasible. It means that impractical to solve in a short amount of time, right? Okay, so cache answer, and then look, new row equals r plus dr, new column equals c plus dc. Then we need to check if is still in the metric. If 0 smaller than nr, smaller than rows. Rows is the number of columns, number of rows, yes. And then 0 smaller equal nc, smaller than columns if it's in with boundary. And also the metric. Look, metric RC is strictly smaller than metric NR and C, right? This is the new neighboring pixel NR and C. Then 1 plus F NR and C return answer. So what about this cache? Yeah, FRC is the representing the length of the longest path. Longest strictly increasing path starting with this position RC. Yeah, the minimum is 1. Yeah, if the neighbors are all smaller or equal than the current pixel, then it will be 1, right? DRDC. Can you explain to me what's this? What's this for 4 vector, 4 coordinate? Look, what's this? 1 0, 0 1, minus 1 0, 0 minus 1. What's this representing?
The car.
The 4 directions. Yeah. Look, this is 1 0. 1 0 means down. 0 1 means right. Minus 1 0 means left. And what's 0 minus 1?
Up.
Yeah, 0 minus 1 is up. Okay. And this is the new coordinate. And then we have to check if it's within the boundary. Yeah, because it doesn't make sense if the new coordinate is beyond the boundary, right? And then we have to check this. What's this? What does this mean? Yeah. If metric RC is smaller than metric NR and C. Right? Do you understand this? Metric RC if it's smaller than metric NR and C. At metric RC, what's NR and C? What are we doing with these 4 directions? NR and C equals, yeah, and NR and C is the next pixel. Okay, so metric RC is smaller than metric NR and C. What does it mean? Can you tell me what's this representing?
If the current one you're on is smaller than the next one,
yeah,
then you can go to it.
Yeah, we can go to it. Where down? Look, we can go to it. How can we do it? We can go to it with 1 more, yeah? Because if we put the 1 more, which is the current pixel, right? It makes the longest path 1 more number, right? And that's the F and R and C is the longest path starting with the next one, right? Yeah? And then if we put the current pixel, that will become 1 more, right? Do you get it?
Yeah.
So if we put a cache, then that means if we put a cache, then it means what? If it means that the maximum number of states we calculating is R times C. Okay, this is the number of states these are calculating. We iterate over each pixel, yeah, and we try to calculate the length of the longest path starting with left. What's the time domestic? So maybe for R in rows, yeah, for C in columns, and answer outside, yeah, answer equals 1, answer equals max, answer FRC, right? FRC. Here, right? So this is OR times C, but for each one we calculate only once, right? So the time complexity is ORC, okay? ORC. Let's call top-down dynamic programming. Yeah? Top-down dynamic programming.
Yes, and you need cache.
Yeah, we need. If we don't put a cache, that will be exponential because for each RC there may be duplicate values. We need to calculate again and again. Okay, that's it for today. Bye bye.
Bye.